Question 24, it's a paper 2 question. The diagram shows 3 graphs. Y equals x, that's that line there, that's function A. B is this function here, which they've called B, and this is the reflection of that function, and that's labelled C. It's reflected in the y equals x axis. Now it says state A, the y-intercept of the function, so that's the y-intercept of B, that is where x is equal to 0, and that resolves down to 8 on 3. 2, the coordinates of the point where C cuts the x-axis. So now we want to find this point here. Well, we know it's a reflection of this point here. Okay, remember these scales are a little bit different, so you've got to be careful here. So that's why it doesn't look like it. It's a 2 and then it's a 4, but here we've got 5, 10. So what we actually want to find is that point there. So where it cuts the y-axis is where it cuts the x-axis here. The coordinates of the point where C cuts the x-axis is actually x is 8.3 and y is 0. Whereas for the original function, x was 0 and y was 8 on 3. B, determine an equation for C in the form of y equals gx. Now we know the function was this, and the method for finding the inverse is we write it with a y in that form, and then we swap the x's and the y's. Then we resolve to make y the subject, and I'm using logs to do that here. I've chosen log base 3 on 2 because I can then remove this. Once we drop y minus 1 to the front, that's going to be y minus 1 times 1, because log to the base 3 on 2 of 3 on 2 is equal to 1. The left-hand side is that. We've got y equals that plus 1. And so the inverse of the original function, which is defined as gx, is equal to this. Part C, write down 1, the equation of the horizontal asymptote of B. That's our original function. Well, if we look at it, we know that the plus 2 would indicate that whereas the original parent function was at the asymptote was at y equals 0, now it's going to be y equals 2. And 2, the equation of the vertical asymptote of the graph y equals 0. Now the vertical asymptote of the inverse function is going to be x equals 2. There we go. Because it's just inverted. There. Good. D, hence state the domain of G. Well, the domain of G is going to be x is greater than 2 because the vertical asymptote of the inverse function, that's a point that the function never reaches, so it's going to be greater than 2 in that direction forever. So that's x is greater than 2. And E, solve the equation, the original function plus the inverse equals 0. And so we just put the original function. We have the inverse equals 0. Now what we did was we used the graph intersection to solve that. We plotted that, and we plotted that with the graphic display calculator, and we found that x is equal to 2.16. Question 25, it's a paper 1 question. Katerina and Carolina go to a swimming pool. They both swim the first length of the pool in 2 minutes 6 seconds. The time that Katerina takes to swim each subsequent length is 5 seconds more than she took to swim the previous length. So that's arithmetic. It's 5 seconds for every length. It's 5 seconds extra. The time that Carolina takes to swim each subsequent length is 1.04 times that which she took to swim the previous length. So this is geometric. State the time Katerina takes to swim the third length. Well, the first term U1 is 126 because it's 2 minutes 6 seconds. That's 60 plus 6 is 126. That's in seconds. D is 5. Okay, that's the difference because they told us that a subsequent length was 5 seconds. So U3 would be 126 plus 3 minus 1. That's n minus 1 times D, which is 5. That's 136 seconds, which is 2 minutes and 16 seconds. 2, show that Carolina takes 2 minutes and 16 seconds to the nearest second to swim the third length. Well, in this case, it's still the first lap was 126 seconds because they both swim the first length of the pool in 2 minutes and 6 seconds. That's 126 seconds. Here we're told that R is 1.04 because every subsequent length is 1.04 times that which she took to swim the previous length. So we use the formula for the nth term of a geometric sequence. That's U1 times R to the n minus 1. And that comes up to 136.2816 seconds, or 2 minutes 16 seconds to the nearest second. Katerina and Carolina swim a total of 10 lengths of the pool. They start at exactly the same time. B, show that Katerina completes the 10 lengths before Carolina. Well, we said that Katerina was an arithmetic, so the summation of an arithmetic sequence is n on 2 times u1 plus n minus 1 times d. So we've got 1485 seconds. For Carolina, we said it was geometric, so the summation of geometric where r is greater than 1 is u1 times r to the n minus 1 divided by r minus 1, and that comes up to 1512.77 seconds to 6 significant figures. So Katerina finishes 10 lengths first. Okay, 10 lengths of the pool first. C, hence state the value of the time difference correct to the nearest second between their total times. All right, so we know that Carolina was 1512.77 to 6 significant figures. Well, from the calculator, I just kept it and saved it, so I've used all decimal places that were shown on the calculator. And then I'm going to minus the Katerina 1485 seconds, and I get 27.76949749, which to the nearest second is 28 seconds. 26. It's a paper 2 question. Mr. Garcia is offered a 10-year contract with a starting annual salary of 20 million Colombian pesos and yearly increases of 5% on the previous annual salary. A, justify that Mr. Garcia's annual salaries over the 10-year period form a geometric sequence and state its common ratio. Well, the yearly increase is 5% on the previous year, which is a common ratio of 1.05. A common ratio defines a geometric sequence. B, determine Mr. Garcia's annual salary during the 3rd year of his contract. It's already been defined as a geometric sequence. U1 is 20 million, R is 1.05, 5% increase, 1.05. Therefore, U3 is U1 times R to the n minus 1. That's 22 million and 50,000. The annual salary in 3rd year is 22.05 million. COP. C, find the total amount Mr. Garcia will earn during his 10 years at the company, correct to the nearest 1,000 pesos. Well, we're using the summation formula for a geometric sequence. That's U1 times R to the n minus 1 divided by R minus 1. And that is 2.515578507 times 10 to the 8th. Correct to the nearest 1,000 pesos, which they've asked for, is 251,558,000 COP. After considering the company offer, Mr. Garcia asked for a different payment plan. He wants to start with the same annual salary but have fixed annual pay rises of X thousand pesos. The company financial manager agrees to this new payment scheme if the total amount for the 10 years remains the same as it was the original payment offer. D, determine the value of X correct to the nearest peso that satisfies the financial manager's conditions. Okay, so if we have a look at this one, we can see that it's now a arithmetic progression here because it says fixed annual pay rises of X thousand pesos. Okay, so that's going to, every year there's going to be a fixed annual pay rise, so it's become arithmetic. U1 is 20 million, because we were told that, right? So the original money was 20 million. It's over here. The difference is now X times 10 to the 3rd because it's X thousand pesos. Okay, that's the difference in this arithmetic sequence. The summation formula for an arithmetic sequence is n on 2 times U1 plus n minus 1 times d. N on 2, that's 5. This would be 40 times 10 to the 6. And we go through there, we've got 9x times 10 cubed. Okay, because that's 9x times 10 cubed. So that's, I've taken 10 cubed out, so it's 5 times 10 cubed times 40 times 10 cubed plus 9x. And then we were told here, part of the condition was the company financial agrees to this new payment if the total amount for the 10 years remains the same. Well, that means it must be equal to this one. Okay, so the summation must be equal to that. So that's on the left-hand side. And that equals what we got here, okay, and we have to find x. We use GDC solve function, and we get that as 1145.730016. And remember, that's in thousands of pesos, so the peso answer is 1,145,730 pesos. Hence, determine the number of years for which the second plan gives Mr. Garcia a higher income than the first. Now, when we say higher income, that means yearly income than the first. Okay, so higher income than the first. Well, we're talking about the terms now. So the first year it was 20 million. The second year was 20 million times 1.05. The third year is 20 million times 1.05 squared. Okay, and what they're asking here is the number of years for which the second plan gives him a higher income than the first. So we're going to compare this plan here, with what he would be getting based on these numbers over here. Okay, so what I've done here is I've used the GDC table, the list and spreadsheet, and I've done plan 1. Now plan 1 is geometric, so I've used the generate sequence in the equation line, which is the second line from the top, the second row. And I've put in here the nth formula for a geometric sequence with all the details that we've got. And I generated, this is n is 7 and n is 8. Okay, and then for plan 2, I did the same. I generated a sequence, but because this is arithmetic, I've used these numbers here, and I've put in the equation for the nth term of a arithmetic sequence, and I generated numbers down here for these values of n. Now, up until number 7, you can see that plan 2 is more than plan 1 yearly. But after year 8, or from year 8, you can see that this plan 2 is now less per year than plan 1 was. So that's the answer, where n is equal to or less than 7. Okay, so there we are. N is less than or equal to 7. And that's the answer for that one. So the earnings for plan 2 are higher in the first 7 years than in plan 1.